In this video, we're going to be looking at completing the square. And that's where we can change a quadratic into a turning point form. So we've got two ways that we can do it. One is I'm going to show you the traditional method, and the other one is the turning point form. So let's get into it.
Our first example is x squared plus 8x plus 2. So let's go ahead and complete the square using the traditional method. So to explain the traditional method, the most important part of the traditional method is this b value here, plus 8. So for our quadratics, we know that the coefficient in front of the x squared is a, in this case 1, b is this number here, in this case 8, and c is the constant on the end. Now when we complete the square, we use what I call a magic number. Now the magic number is this b value, but it's half of this b value, okay? So 8 divided by 2 is 4. So in this case, my magic number is going to be 4. So I set up my expression like this. Open brackets, squared, x, and I'll put my magic number in here. My magic number is 4, in this case plus 4. So x plus 4 squared. Then I subtract the same number squared, again, like this. So 4 squared, I take it away. I usually put it in brackets here just for clarity. Then we finish off the equation with the constant, so plus 2, and then we simplify. So 4 squared is 16, negative 16 plus 2 is negative 14, and now we have our completed square form, x plus 4 squared take 14. It's a pretty simple process. Let's have a look at another example. In this example, we've got x squared plus 4x take 7. Again, our magic number is based on the b value. So our b value in this case is 4. If I divide that by 2, my magic number is going to be 2. So I set up my expression in brackets, x, and I'll put my magic number here. In that case, it's plus 2 squared. And then I subtract that magic number squared again. And then I whack on the constant at the end, which is take 7, and simplify. So 2 squared is 4. So this becomes take 4, take 7, which becomes take 11. So x squared plus 4x take 7 in completed square form is x plus 2 squared take 11. In this third example, we have a b value which is negative. So you need to be a little bit more careful with negative b values. So our b value is negative 4, and if I divide that by 2, I get negative 2. So my magic number is negative 2. It's exactly the same process. X take 2, pop that in there, all squared, take my magic number squared. So look what I do here. In my brackets, I put my magic number squared, and whatever the result of that is, I subtract. Okay, and then I put my constant on the end, which in this case is negative 5. Okay, so this negative 2 squared becomes positive 4. This part's positive 4, but I'm taking positive 4. So that becomes take 4, take 5. So we've got negative 4, take 5 becomes negative 9. So in this case, our completed square form, or our turning point form, is x take 2 all squared take 9.
Number 2, the turning point form. Let's try those same examples with the turning point method. In the turning point method, we actually find the turning point and then create the equation from the turning point. Again, a, b, and c, they are our numbers. To find the turning point from an equation like this, we use our line of symmetry. Now our line of symmetry has a little equation, which is this. The line of symmetry is when x equals negative b over 2a. And the b's and the a's are related to these coefficients here, which we spoke about before. So let's put these numbers in here. In this case, we want negative b on the top, so 8, so it becomes negative 8 over 2 times a, which is 1 in this case. A is 1, so negative 8 over 2, and that becomes negative 4. My x value for my line of symmetry is negative 4. Now we need to find the y coordinate at that point, because that is where our turning point is. So I'm going to put negative 4 into my equation up here, just like this. So negative 4 squared plus 8 times negative 4 plus 2, according to this equation. Let's simplify that. Negative 4 squared is 16. 8 times negative 4 is negative 32 plus 2. We simplify that down to negative 14. Now our turning point is negative 4, negative 14. That's what I've just established through this method here. If you know your turning point, then you can write your equation simply like this. X plus 4, when it's negative 4 here, it becomes a plus 4. It's the opposite sign. So x plus 4 squared, and then the y value, take 14. So in this case, we've found the turning point and we've made the equation here, and the resulting equation is actually the completed square form, which is also sometimes called the turning point form. Let's try another example. X squared plus 4x take 7. A, B, and C, I've identified there. We find our line of symmetry, negative b over 2a. So I'm going to put negative 4 over 2 times 1. Negative 4 over 2 times 1 is negative 2. So x is negative 2, that's our x coordinate. We need to find our y coordinate. Simply substitute negative 2 into our equation. Negative 2 squared is 4, and 4 times negative 2 is negative 8. So we get 4, take 8, take 7. That becomes negative 11. So our turning point for our quadratic is 2 and negative 11. And therefore we can write our equation from that. It's the opposite sign of this one. So x take 2 for our x squared, and then our y coordinate, which is take 11. And that is our completed square form. And now we have our negative b example. It works exactly the same. So our line of symmetry is still negative b over 2a. In this case, b is negative 4. So if I find the negative of negative 4, it becomes positive 4. So it's going to be positive 4 on the numerator over 2 times 1 on the denominator, like this. Negative 4, so that becomes a positive 4 over 2, which is 2. Substitute that in. 2 squared, take 4 times 2, take 5. Gives us 4, take 8, take 5, which gives us negative 9. Our turning point is 2, negative 9. And now when we write our turning point form, or our completed square form, it is x plus 2, again, the opposite of the x value here, squared, and then our y coordinate, take 9.
I know what you're thinking, but what happens if we've got a non-monic quadratic? Don't worry, got you covered. Going to show you how to do it right now.
How do we deal with a non-monic quadratic? We've got a 3 here instead of a 1. The process is the same, but we need to do a little step first. Firstly, we need to make a monic quadratic. So what we do is factorize out this 3. Okay, so bring the 3 out the front, factorize this out, take the 3 out the front, leaves us with a take 2x, factorize a 3 out the front for the negative 45, and it becomes negative 15. If they don't factorize nicely, they can be fractions and it still works. Okay, so now we've got this new equation here. We've factorized out the 3. Now we have a monic quadratic in the brackets here, where my a coefficient is 1. So now my a coefficient is 1, b is negative 2, c is negative 15. We're going to complete the square of these brackets first, and then we'll just multiply everything by 3 at the end. So let's do that. Working this one, my b value is negative 2, and we know that with the magic number that we need is half of that. So negative 1, pop negative 1 in here. Take the magic number squared, and then take 15, because that's our constant there. Simplify that. This one becomes positive 1, but we're taking the positive 1, end up being take 1. Take 15, and we get x take 1 squared take 16. Now once we've got this, remember this is just the inside the brackets part. It's just this part here. So we need to multiply everything by 3. So I'm going to multiply all that by 3. So 3 times x take 1 squared gives us 3 outside of x take 1 squared. And then 3 times negative 16 is negative 48. So now we've completed the square for 3x squared take 6x take 45. It's this 3 outside of x take 1 squared take 48. And it has a 3, which is our original a value out here, take 48. So that's how we do it using the traditional method. Our final example is where we're going to complete the square using the turning point method. Right, so we go through exactly the same process for this one. We don't need to factorize out. We can just use these numbers as they are. So a is 3, b is negative 6, c is a negative 45. We find our line of symmetry, negative b over 2a. b is negative 6, so it's going to be positive 6 over 2 times 3, 3 being our a value. So it'll be 6 over 2 times 3, which is going to be 6 over 6. So x is 1 in this case. We know x is 1. Let's put 1 into our equation here to find our y coordinate. We simplify that down and it becomes negative 48. So my turning point is 1, negative 48. Now here's the trick, is we need to bring this 3 back in there again. Okay. All you need to do is do exactly the same as we did before. So x take 1, because this is positive 1, we use the opposite sign. X take 1 squared, take 48. And all we do is we whack the 3, boop, right in front of here. So if a is 3, up here, a is 3, we just pop the 3 here, and that is now in completed square form, just like we did using the traditional method.
So there you go. There's 2 ways that you can complete the square. Hopefully you find that useful in your studies. If you did, you know what to do. Catch you in the next video.